Mr. Ryan, right?
Yeah.
We have been talking about the minimum gene problem for like 2 days, okay? So, gene, A, C, G, T, right? There are 4 types of gene. A pair with T, C pair with G, okay?
And?
Okay, so we given this star gene, remember we have a star gene, A, C, C, T, something like that. And for each mutation, we can pick a gene and mutate it and change it to 3 other types. Okay, and let's call one mutation. So basically, this is the
How much mutations?
this is the graph problem. This is the undirected, unweighted graph, and we want to find out the minimum number of the mutations to mutate from the star gene, right, to destination gene. Okay. Okay. What's that? That's coding, yes.
Fact.
We can use the breadth search, okay? Breadth search. And depth search, we talk about depth search, right? So breadth search, level by level. Level by level. This is a graph, undirected graph problem. Undirected, meaning that if A changes to T, T can also change to A. This is undirected. Unweighted graph. The cost of each mutation is 1 step. Okay. Okay. Yeah, that's it. Each mutation is 1 step. That's unweighted. This is the star gene, and then for example, this is the destination gene we are looking for. So we can perform a breadth search level by level. And then each mutation has to be in a list of the genes defined in a bank, right? Let's bank of gene, and we convert that to a set for a faster lookup. Breadth search. And depth search, we talked about that last lesson. So we use the depth search to explore all the paths in this gene tree, right? So the problem with depth search is that the first time it finds, for example, if this gene is here, and it could be another mutation, the same gene could be here. So if we perform a depth search, right, it could find this one instead, and this is not the optimum. The optimum is this one. So in order to do that, we have to explore all the paths. Brute force. We brute force using the depth search. Then we know this one is the optimum. Okay. Yeah. Okay. So today we're going to talk about the iterative deepening search. We talked about that before, right? Iterative deepening search is actually the depth search. We have this iterative depth search. So what does it actually mean? So iterative depth search. Okay. Okay, let's what's iterative depth search? So it means that look, at the beginning we set the path to maximum depth is to 0. So if this target is here, right? Target is here. So we set the depth to 1, and we perform a depth search with the limit depth equals 1. So it's just this node. This is not a target node. Then we increment the depth to 2.
That's breadth search, because you're basically doing that.
That's good point. It looks like a breadth search, but it's not. We set the depth to 1, and then we perform a depth search here. And then we set the depth to 2, we perform a depth search here. Okay. Okay, so look, what's the iterative deepening search? If I label the node, okay.
That is a really long
Okay.
road.
Okay, that's it.
Look, that is in really long for a road.
Okay, so you know the breadth search, yes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Right? We're using the DQ, double DQ. First in, first out.
It always start with the left.
Yeah, and then the depth search, you go as deep as you can, right? So 1, 2, 4, 8, 14, 15, 9, this way, okay? Okay, that's it. Too much. Okay. But what's iterative deepening search? So look, if I set the depth, the limit depth equals 1, equals 0 at the beginning. So we perform a depth search. So it's just this node. Yeah. If we don't find it, if we are targeting this node, 15, okay? 15. If this is the node we are looking for, 15. So depth equals 0, we don't find it. Depth equals 1. So we perform a depth search. Look, we perform a depth search in this tree, but maximum distance is 1 to the root. So it's 1, 2, 3. Okay? We still don't find it. So let's increment it to 2. We perform a depth search with the distance 2. So it's 1, 2, 4, 5, 3, 6, 7. Okay? We still don't find it. We increment this depth to 3. Can you tell me what's the order when the maximum depth equals 3?
1, 2, 4, 5, 3, 6.
No, depth is 8, 9, 5, 10, 11, 6, 3, 6, 7. Yeah?
If this is 1, then that's 2 and
Oh.
that's 3.
No, this is 0. 0, 1, 2, 3. Okay? Yeah. So step equals 3 is 1, 2, 4, 8, 9, 5, 10, 11, 3, 6, 12, 7, 13. So we still don't find it. So we increment depth equals 4. We perform a depth search. 1, 2, 4, 8, 14, 15. Okay?
No,
This is 15.
No, 15 is over there.
Okay. Okay, we find it, yeah? Okay. So what's the iterative deepening search? Any of you explain to me what's this? So
It's iterative deepening search.
So you have a depth and you go up to it and search all of it.
and then if we don't find it, we increment it, right? So it's actually kind of like breadth search, but it's incremental. It's using the depth search incremental, right? Right, level by level. But inside, when we determine a next step, we use the depth search. Okay, right? Okay. Okay, so we can use this to solve this problem, right? Let's write a pseudocode. T equals 0, okay? Depth equals the length of bank, right? This is the maximum distance, right? Because all the mutation has to be in the bank, okay? So while D smaller or equal than D, right? Then we do this. If depth limit search with the star, with the N, with the D, then we return. If we find it, then we return it, which is D. Okay, that's the shortest distance. Otherwise, D plus equal 1. Right? And if we don't find it, return minus 1. Depth limit search. So we perform a depth search, but with the given D. Okay? So we're passing this D to it. Okay, that's it. Important thing here is depth limit search. We're passing the D. We increment this D. Okay? We increment this D. Okay. Define depth limit search. Star N E. Star N and D. Okay. And we also need to define a scene, a hashtag, to remember the nodes we have visited before. If S equal E, then return true. Right? We find it. If the S is in scene, or the D falling below the 0, meaning that we have existed the maximum D, then we return false. Okay? And the first thing we put it in the hashtag scene.add S. Okay? And then at the end we need to remove it. Return what? Return false here. And then the mutation for I in what? Come on. What you doing? Come on.
I in range.
ACGT, right? For K in range length of S. So the neighbor, the next one will be N will be S up to K plus I plus SK plus 1 up to the N. If N not equal S, and depth limit search, the neighbor, the N, the D minus 1, and the scene, and then return true. And also the bank, right? Because this N needs to in the bank, right? This defines the valid edge. On the left hand side, this is the iterative deepening search. So basically we increment the D until we found it. But inside, we use the depth limit search. Depth limit search is so depth limit search. What is depth limit search? It's a depth search with a limit. with a limit. Okay, so depth first search, we just do this until we find all the nodes, right? But depth limit search, if we saying okay, we have a hard limit at here, so depth limit search we will do this. We're not going down because it reaches the limit. Okay, so we do the depth limit search. If we find it, we return the D. Why we can return the D here?
Because it went to the limit. Because we want to see like the minimum.
Yeah. So you see, so we depth here, we found it. Then it's the shortest, right? If not, we increment. It's like a breadth search, but we're using the depth limit search. Okay. So look at this D. Okay, you understand this part, right? And this part is depth limit search is the depth search with the limit. So what's the difference between this one and depth search? Here, D.
Is longer.
Yeah, no, D. Here we check. If we reach the limit, we return the false, right? And then we change this to D minus 1, right? This is the difference between depth limit search to depth search.
It's reversed and longer.
Yeah, and all other bits are the same, right? Okay, so that's it. What have you learned today? And that's it.
About mutation, depth limit search, and iterative deepening search. So we check a tree. So we have like this tree, and we have this like target, and we want to get like the and so and on the left side we have a smiley face, and so the approach is like, okay, so we have this a limit, and we search until we reach the limit, and if we haven't got it, we reach more. We plus 1 to the depth, and we search that part until we get it.
Yeah.
And on the right side is basically the opposite, and
Limit.
and you start from the and then you minus the depth on the way.
This is checking the limit, okay? Checking the limit because we're passing the positive depth here, right? So when it falls below or equals 0, then it means that it reaches the limit, then we return false, right? Return false means that we can't find this node within this limit, okay? And this is doing calculating the this is the neighbor. Yeah, n is the neighbor node, the mutation. If it's not equal to s, we need to check if it's equal to s, right? Because it could be possible that the neighbor node is the same.
Yeah.
The depth limit search, we updating the limit. Okay, and then this has to be in the bank. Okay. Okay, that's it for today. Bye.
Bye.